So lesson 23, intro to probability. Here is your vocab. Let's see. The law of large numbers. Just think about this, like, flipping a coin. If you flipped a coin like 10 times, the probability of getting heads or getting tails, you already know is 50%, but you really wouldn't see that particular theoretical piece of it, right? That it is 50%, if you only did it 10, if you flipped it 10 times. But if you flipped it over many times, right? That's why it's law of large numbers. Then it does. You will reach that theoretical probability of the half, as far as that goes. Heads is 50%,
So like
tails is 50%.
So it's assuming infinity?
What?
You're saying eventually it'll equal 50-50, right?
It does, yeah.
Without assuming infinity for it to eventually equal 50-50 probably?
There's no telling when it'll be, but you will get it. But that's why it is 50-50. Okay. Make sure, as far as the sample space goes, that it is the set of all possible outcomes. There is no overlapping as far as the sample space. And then that is a complement with an E, not with an I. It's A prime, or you can say the superscript of A to the C, but that's notation as far as the complement. All right. Let's talk about random events. So random behavior. Why do we randomly assign treatments to groups? Why do we use a random sampling to choose groups? Why does the NFL use the coin toss as far as to determine possession of the ball at the beginning of all football games? Okay. Of course, we strive as far as using like the flipping of the coin to take out the bias part, to have a random selected piece on there. I just talked to you about the law of large numbers. Now, would you agree that the outcome as far as something never occurring, the probability is 0? Okay? And that's something of an outcome that happens every time, always happens, is a probability of 1. All right. How about, have you ever heard, playing in a casino long enough and the house always wins? Have you ever heard that? Because they do win, right? All right, so let's talk about some misconceptions. I heard this analogy as far as like flipping a coin. The coin does not know that if you flipped it like 6 times in a row that it got tails. Coin doesn't know that. So you would kind of think, though, that, the next time I flip it, I'm going to get heads. It doesn't know. That's why it's always, with every chance, it's always 50-50. You just do not know. So you can't always, think about, surely I'm going to get, heads on the next one, even though I got tails 6 times. So you got to think about that. The coin has no control, no idea. Unless it's, of course, weighted, or the dice is weighted, or whatever. All right.
Would the law of large numbers still apply to things like the lottery and stuff?
I would say so, yeah. Okay, so that thought process, as far as what I was just talking about, like you have the coins, the dice, and also any games of chance, they do not have memory. So they call that thought process the law of averages, with that common misconception. Okay, running a simulation. It is a 4-step plan when you're conducting. So the first thing is for state, plan, do, and conclude. So you always want to state the question of interest about some chance process. We're going to plan, so you describe how you're going to simulate the chance process. You got to be detailed on how you will imitate one repetition of the process. Make sure that you tell what you're going to record at the end of each repetition. Reputation. Repetition. All right. Number 3, do perform many repetitions of this. I'm gonna say it again, of the simulation, and then conclude. So use your results. I underlined that a couple of times to answer the question in context. So guess what? Context. Okay. So the one we're actually going to apply this to is in conjunction with the Coca-Cola is running a promotion at the football games. The concession stand is selling Coca-Cola bottled sodas for $2.50. Customers have a 1 in 6 chance to win a $10 gift card with the purchase of every bottle of soda. Under the soda cap, it says you're a winner or try again. Out of the first 10 customers who buy a soda, 5 of them win. So Mr. Swenson is concerned that 1 in 6 claim from Coca-Cola is inaccurate and he may lose money. We're going to test this claim for him, okay? We're going to assume that the claim is true, that for every bottled purchase has 1 in 6 chance of being a winner. We're going to run the simulation to test the claim. Roll your die, you should have one in front of you, all right, 10 times to simulate the 10 people purchasing a soda. If you roll a 1 through 5, those are considered losers. And you roll a 6, that is a winner. Okay? So every time you're rolling, you're going to repeat this again so we can have 40 or more repetitions of the simulation. All right?
So wait, for the first simulation, we go just roll 10 times.
Yeah. So,
No.
it says use the 4-step plan to answer the question. So, we did, what's the first thing? It says state the question of interest about some chance process. Okay, well the question was asking, does it seem plausible that Coca-Cola's claim that 1 in 6 are winners is accurate?
Plausible.
It's plausible.
I'd say it
I
is.
mean, look at that. Yes.
I mean, you're more likely to get a 4.
Yeah.
Wait, why is? Oh wait.
Well, we don't know
Why
that
is the
'cause our-
56 one
'cause their
longer
data's
than the
off.
61 one?
Because
Like,
everyone's
way longer.
things were.
We're missing 32, so technically those could have
No,
been
but
filled
I
out
think
long before.
significantly.
Whoever went last, do their jots tiny.
That was Palmer.
That was Palmer.
Still, he put tiny-
But she counted everything. Tanfield got
He
it.
had more tiny bells than 56 and 61.
I think we added some random.
All right.
Yellow numbers.
So what? All right, so we're going to go off of the 4-step plan. Okay. So state the question of interest about, so that we already had the question, right? So describe how you are going to simulate the chance process.
We're rolling the dice, 1 out of 6.
Be detailed how you will imitate one repetition of the process. Make sure to tell what you will record at the end of each repetition. Okay? That's step 2. That's your plan. All right, so our question's already there. I'm reading on the very front page what we're supposed to be doing. Okay? So give me an example of how we would describe how we're going to simulate.
We will roll a 1 through 6 dice to simulate the 1 through 6 chance.
Okay. So go more detailed than that.
We will go do it 10 times.
Alright, state the question first. Is it plausible?
That's the first thing. So then what else do we need to say though in our plan?
We will have multiple people do it.
How many times did we simulate?
40.
10.
400.
Well, we did 10 the first, but then we did 40, right?
350.
So we did, our class was 358, right? And then, but what are we supposed to, how did we define if we won or not? 1 through 5, right, was try again, and then 6 was winning, okay? So that would be something on how you would have to be detailed, okay? Then the do is perform many repetitions of the simulation. Well, we did, right? We did 10 at first, but then we actually did 40 to help with the larger numbers, right? Okay? And then conclude. what can we, by using our results, it says use our results to answer the question in context. So how can we conclude that?
Should be the number.
Using our results to conclude that.
We decided it's wrong.
Conclude the questions.
So does it seem plausible that Coca-Cola's claim that 1 in 6, right?
So
Because
we say it seems plausible that 1 in 6 are women.
okay.
Alright.
Yep.
The question first.
And the question's there. You don't have to like rewrite it, but it's there. So you can just put like that's your number 1 for just for
That's right, word for word.
like that would be your state, right? Then you have your plan. There's actually a quiz that is like this. It has the state, the plan, the do, conclude. I was thinking about doing that, but why? Because then you can't be on your phones.
No, because I have to write, and my hand is tired. I'm like agile, young.
No, I actually would put you in groups to do it, but I don't know. I'm still thinking about it.
Don't worry.
Okay,
I'm not.
You're so strong, Agnes.
so this right here is your state, right? Then you would write exactly, we actually talked about what each one would be, okay? Are we good? We're almost done. So we're on the last page, okay, the last side. And it's just because we did that activity for the simulation piece. What would your sample space be?
Are we not going to write it down?
We already talked about it. You write it down.
I'll be right.
And I'm only doing it for time, is the reason why I'm not writing anything down. All right.
Do you have it though, so I can take a picture?
No, don't. Because, I mean, it's something that,
So we don't. Are we guys actually writing? Like, are we guys writing them all out during test?
I don't know. You're already talking about the next test?
Yeah.
I don't know. I haven't even,
Next one we have.
I'm getting through today.
We're not having a good test.
A good student.
What?
Is that why you never understand what's going on in class? You always think you
He's always listening to what? He's only listening to like 1%
He said a good
of.
student looks to the future. That's why he's never listening to class.
Oh my gosh. Okay, so
You only scored 1 point higher than me. What does that say about your listening skills?
Your point's higher.
No.
She gonna give me that credit.
what would the sample space be for rolling a 4-sided die twice? What would that sample space look like?
Oh, foresight.
Wait, what? Rolling a four.
I'm on number 1 on example 3.
What the crap is a foresight die?
Yeah, but just think about it.
Is that diamond? No, it's gonna be round.
Rolling it twice.
Yeah, we're gonna roll it twice. So what would the first time be?
One out of four, and then one out of one.
So we have a,
Oh, it's a triangle dice, isn't it?
yeah, so like, the first one would, you'd roll a 1, right? A 2, 3, 4. That's representing my first roll, yes. And then the second roll would be, right? And then I would repeat that for all of them. That would be my sample space. Do you agree?
That's all we have to write?
Now, if I had to list it all out, I mean, I could draw it in a diagram form, but if I had to list it out, okay, well, my first one is rolling a 1, and then my second one is rolling a 1. Then I could roll a 1, or I can get a 2. Roll a 1, 3 on my next one.
Is it easier to list or draw? Probably easier to list, right?
Well, I think the diagram is easy to draw, but then you would probably have to roll it out into,
If I write it out,
yeah.
but it's easier to draw.
Well, I mean, those are kind of easy to see, but yeah.
Just for number 2. That one, 1, 2.
Okay. Now, if I had to list them all out, how many would we have as far as in our sample space goes? How many would you have there? I'm trying so hard not to scooch this up.
You mean,
If I listed it all out, how many would I have in my sample space?
16.
I would have 16, right? Okay. So what would, let's scooch it up just a little, okay? What would the probability be for each of those 16 outcomes?
1 of the 16.
1 out of 16 for every single one, right? Very good.
So small.
So like rolling a 1 and a 1, 1 out of 16. Rolling a 1 and a 2, 1 out of 16. So you would have that for all of your 16 outcomes.
Is this like matrices? And all of that? No?
What is the probability of any event? The probability of any event is number between what and what? 0 and 1. Very good. You can also put it, if we had to write it in mathematical notation, you would say that the probability, let's just say, let me call it E for event. But you could say that it would be 0 all the way to 1. This is saying that the probability of it is never happening, right? Never happens. This is saying that it will always happen. So if I had to sum up all of my probabilities of whatever particular events it is, it better be add up to 100.
I rolled this 3 times. That whole string is a 1 in 1296. That's crazy.
So if I summed up, well, exactly what I just said. If I summed it all up, what would they come to?
1.
A 1. Because probabilities is just a percentage, right? Which is just decimal format, which, of course, those decimals would add up to a 1.
I'm expecting our test just to be like, you got 10 marbles in a bag, 4 of them are
I
red.
expect our test just be us rolling
I
dice.
have done a lot of those problems, yeah.
It's gonna be the cards.
Oh, I like it.
Yeah, I don't understand cards.
Hey,
Yeah.
if you just want us to roll dice.
52
maybe
cards.
that's
We'll go
card
through the
test,
cards,
I'll
don't
show
worry.
you.
All right.
We
Um,
have to win a poker game.
We do it.
Uh,
That's your test.
that should say the probability of event A right there. So the numbers of event A, we'll just call it that.
You can win BS.
So the probability of an event A occurring is the total number of outcomes of event A divided by all of the number of outcomes in that sample space.
Melton for your focus class. Please make your way to the cafeteria at this time to choose your elective classes. Thank you.
So the probability of event not occurring, or the event that does not occur, do you remember it's 1 minus whatever the probability of it is occurring? That's your complement. You'll usually apply that sometimes. Sometimes it's easier just to do the complement of something than it is to, like sometimes you're summing up particular things.
Does this usually get hard?